Hi guys, welcome back. So in this video we are going to see how we can create our first ERC20 token, and I'm not just going to add the mint or transfer function. I'm going to write a detailed ERC20 token based on the ERC20 interface provided by OpenZeppelin. So if we go here, we can see this IERC20.sol, and I have explained interfaces in my previous videos. So if you don't know what the contract interfaces are, you can go to my other video and you can see what the interfaces are. So basically in this interface, these events are defined and these functions are defined: balance of transfer, allowance, approve. So basically these allowances, you are allowing someone to spend the tokens on your behalf, and this approve function, actually it runs this allowance function so that people can actually approve. Let's say you want to allow a smart contract to spend the token on your behalf, so you are going to approve this spender, the smart contract address, or let's say your friend's address, and you are going to say the amount, like, okay, I want to allow my friend A to spend 50 coins from my account. So basically this is the allowance. I'm going to explain it in the smart contract we are writing. And so here I have set up the project already. I have installed npm init. I have installed these packages and I have initiated a Hardhat project. So if you don't know how to do it, you can go to this video and you can see how you can create your first Hardhat project, and you are going to get a step-by-step guide. So basically where the video ends, where you actually create a Hardhat project and start writing your first smart contract. So from there the video begins. So let's start writing the smart contract. First of all, I'm going to copy some things which are like same for every smart contract. So we are actually importing the interface ERC20, and this is the onable and initializable. So basically this IERC20, this is the interface I showed you earlier. This onable, this is a library which allows to set the owner of the smart contract or to change the ownership by OpenZeppelin. And then this initializable, basically this is a Solidity smart contract to actually allow you to initialize the contract once, and you can consider it as a constructor. So if you want to see these files, you can just copy and paste this and put it in the Google, and in the first link you can actually see these contracts, the source code of the contracts. So let's start writing the code. First of all, we have the name of the token and the symbol of the ERC20 token, and finally decimals. So, and it's not string, sorry, it's unsigned int 8. So basically these decimals are like this. So if you know 1 ether is equals to 10 power 18 V. So V is actually the 18th part of ether, and you can say 1 V is equals to 1 divided by 10 power 18 ethers. So this is the 18th part of this ether. So we can also define these decimals in order to express our coin in fractions, just like ethers. So we are going to give this value in our constructor, and there is a mapping of address to unsigned int 256, and these are actually the balances of all the addresses. And then there is a mapping, it's nested mapping of address and address 256 private allowances. So basically it's like this: allowance address is equals to amount. So basically you are saying that this is your friend's address, he is allowed to spend your coins, and this is the amount of coins. So we are going to see in this video how we can define those functions. And finally, unsigned int 256 private underscore total supply. So this is the total supply of the token, and we are going to define it in our contract. So first of all, we are going to write a function initialize. You can consider it as a constructor. So string memory name, string memory So basically in this function we are going to give these parameters, and we are going to say it's a public function initializer, and we are going to say underscore name is equals to name underscore symbol is equals to symbol underscore decimals is equals to decimals underscore. And then we are going to define a function mint. I'm going to explain this function after writing it, and I'm going to explain what I'm doing here. It's done. And finally, the transfer ownership function from we are going to say the transfer ownership to message.sender. Okay, so let's first write the mint function, and then we can actually define what is the mint function doing here. So we have our function underscore mint, and it's going to take address, account, and unsigned int 256 amount, and it's an internal function, like nobody can call it from externally, and it require account address should not be equal to 0, and we can say ERC20 error cannot mint tokens to 0 address. And then what we are going to do, we are going to say right now the total supply is 0, so we can say total supply plus equals to amount, which we are going to pass from our input values, and then underscore balances of account plus is equals to amount. And then we are going to emit a transfer event address of 0, account, and amount. So basically what we are doing here, why I'm getting first of all, we are initializing. So this is the name we are providing, the symbol we are providing, and the decimal we are providing, and then we are transferring the ownership to this message.sender, who is going to call this function, the owner of the smart contract. And this mint, it is actually minting the tokens, like it is creating tokens, and these are like 360 zeros, like unit 100,000, so 10 lakh tokens, like 1 million tokens, and it's 10 power 18. So basically it's 10 power 18. So we are minting 1 million token, and we are going to give this token to this address, this message.sender, who is calling this function. So all these token supplies, it's going to the owner of this contract, and the balance of this account, this message.sender, who is going to call this function, he is getting all the tokens. And then finally we are going to emit an event, and where this event is coming from, this event is basically coming from here. So if you see event transfer, this is the address from address to and unsigned in 256 value. We are going to set this address to 0 because we are not getting tokens from anywhere. We are minting the tokens like freshly. And this 2 is the address. So basically if you go here, this 2 is the address of the account. So we are minting the tokens. There is no address where we are getting this, so we are putting it 0, and this is the account where we are sending the tokens, and this is the amount. So this is done, and then we are going to write a function name public view returns string memory, and it's going to return name of the token. Then we are going to define another function symbol. It's going to return the symbol, and then we are going to write a final function decimals, and it's going to return the decimals of the, and here it's not string, we are going to return unsigned int 8. Okay, so we have these functions now. I don't know, okay, why I am doing this. Okay, then we have a function of total supply, and it's also public view returns, and we are going to override it because it's the same function which is defined in the interface. And we can return total supply. Okay, and then we are going to write some functions where we are going to write function balance of, and we can say address of account public view override returns unsigned int 256, and it's going to return underscore balances of account. So basically you must be wondering why we are writing override here. So if we go back to our interface contract, we can see that, you see, we have this function total supply, and this is the function balance of. So when we are importing this, like my token is IERC20, so we are inheriting all the functions in this token contract. So we have to explicitly mention this override word, so that the functions which we are getting from the inheritance, this function must override that function, so we can use it. And why it's giving error? Okay, because we have not put semicolon. And then we are going to write function transfer address recipient and unsigned in 256 amount. So basically this function is going to define, we are going to transfer the address from sender to this receiver, and this is the amount which we are going to send, and it's going to return a bool, either the tokens are transferred or not. And in this function we are going to define another function which is an internal function. So this is the best practice you have to follow while writing the Solidity smart contracts. And then we can say return true. So if the transfer is done, then we are writing return true. And then we have function transfer. It's going to take address of sender, address of recipient, and unsigned into 56 amount, which we are going to mention, and it's an internal function. So this function cannot be called from outside, only this function can be called from outside. So when this function is called, then this function will be called automatically. So in this function we are going to see something: require sender address must not be equals to 0, and we can also do the same thing: recipient is not is equals to address of 0, and then we can say underscore balances of sender. We can minus or subtract the balance of the amount which is being transferred, and we can increase the same amount in the receiver's address. Balances recipient plus is equals to amount. So basically we are adding this amount, and then we can emit an event that this sender has sent this receiver this amount of money. So we have written this transfer function, and now let's write our so here our functionality is almost done, where we are actually transferring the tokens from one address to another address. So now another thing which we want to do is to implement these two functions like allowance and approve. So basically in the approve function we are going to allow a spender to spend the tokens on our behalf, and then we are using transfer from function so that we can send the tokens from this address to this address if we are allowed to do so, if we are allowed to spend the token on someone's behalf. So okay, function transfer underscore transfer. So let's write our function approve, and here we can say address of spender and unsigned to 56 amount, and it's public. Again override, because we are overriding it, which is being inherited, the function which is being inherited from this ERC20. And again do the same thing which we did with in the transfer function: approve message.sender spender and amount, and finally return true. And now we are going to implement this underscore amount function underscore amount, and again it's going to be an internal function. We can say address of owner, who is the owner of those tokens, and what is the address of the spender. Let's say this is the address of your friend whom you are allowing to spend the tokens on your behalf, and then we have address of amount, what is the amount of tokens, and this is internal. Again it requires the same thing, so I'm just going to copy and paste this, and here the address of not sender, it's owner, and the address of spender. So basically, oh, I think I made a grave mistake. It's okay. So once these addresses are done, what we can do is underscore allowances of owner, if you are the owner, and spender is equals to amount. So if you go at the top, we defined these allowances. This is a nested mapping like two addresses. So this is your address and this is your friend's address. So you are allowing your friend to spend the tokens on your behalf, and this is the amount of tokens. So we are setting it here. This is the amount, and then we are going to emit an event like who is the owner, who is the spender, and what is the amount. Again, this approval, you can actually go to this contract and you can actually see this event approval. which take the address of owner, the address of spender, and the value. So now our function approve is written. So if I want to see if some owner or spender are allowed to spend on someone's behalf, I can write a simple get function to check. So we can write function allowance, and it take the address of owner and address of spender, and its public view override returns the amount, which is unsigned in 256. So basically this function takes the two addresses and it tells us that if something or if some address is allowed to spend on someone's behalf, allowances of owner and spender. So it's going to return this. So this actually, this double array, like this 2D array, it's storing the amount which can be spent based on this spender address and owner address. So it's going to return this, and once we have this approved, we can simply write function transfer from address of sender, address of recipient, and unsigned in 256 amount. And again, this function is being inherited from the interface, so we are going to override it. Returns, it's going to return bool, either it's transferred or not. And if you want to transfer the token, you are going to use this function underscore transfer. So what we are going to do, transfer, and who is the sender, who is the recipient, and amount. So basically this function can be called by someone whom you have allowed to spend the tokens. So let's say here it's your address, but you are not calling this function, your friend is calling this function. So you are the sender and let's say I am the receiver, and your friend is calling this function where he is putting your address and then he is putting my address. So basically when he calls this function, your tokens will be transferred to me just because you have allowed him to spend the token on your behalf. So after this we are going to see if the spender is allowed to spend your token, and then we are going to say allowances of sender and message.sender minus amount. So basically if the spender return true. So basically what this function is doing, so first of all it is transferring the tokens from sender to recipient. So it's going to reduce the balance, your balance, it's going to increase my balance. Once it's done, it's going to approve the sender, message.sender, and amount. So it's going to come again to here and it's going to update these allowances. So if I have allowed, if you have allowed your friend to spend 50 tokens but he already spent 25, like he sent 25 tokens to me, this address will be updated. So what is the current allowance minus the amount which he has sent me. So this amount will be updated, and if it's 50 minus 25, so the 25 tokens will be remaining tokens for your friend to spend on your behalf. So once this is done, we can actually create two more functions where we can increase allowance. Like we can increase the allowance. Let's say you allowed your friend to spend 50 tokens on your behalf, but you changed your mind and you said, okay, I can allow him to spend 100 tokens. So you can add added value, and then you can call this function public virtual returns, and it's going to return bool, and then you are going to call this approve function, where you are going to say message.sender spender, and this same underscore allowance plus added value plus added value, and here it's not sender, it's message.sender, and this is the spender. So this is the spender address, your friend's address, and it's simply return true. And we are going to add another function, decrease allowance spender, and it's not added value, it's subtracted value, and public. Okay, and instead of this added value we are going to write subtracted value. Okay, so our function is almost written, and we can try npx hardhat compile if we have any error in this code. Okay, so our code is compiled successfully and we have written this code. So I will just go through the code again. First of all, it's initializing the name, symbol, decimals, then it's going to mint and put all the tokens in this account address, and then it's going to define name, symbol, decimal, total supply, balance of function, where they are going to return the balances, the name, decimals. This is the main transfer function, which actually transfers the token from sender to receiver. This is the approve function, which actually approves a spender to spend the token on your behalf. This function returns how many tokens a spender can spend on your behalf. And finally, this is the transfer from, like the spender can actually call this function and he can send the token from your address to any other address. And you can actually increase allowance or decrease allowance. So based on your based on your preferences, if you want some spender, your friend, to increase the allowance or decrease the allowance. So once we have written our smart contract, we can simply write index.js, where we are going to test the functionality of this token. So if we actually we can call these functions and then we can see if the functionality is implemented. So I'm just going to copy and paste the same thing which I have copied and pasted in my all previous videos. So you are just going to import ethers, then you are going to define API URL, which we are going to put it in provider. Like this is the provider, the blockchain, what is the name or what is the address of the blockchain which we are going to connect to. This is the private key of the account, and then this is the signer who is going to interact with this contract, and we are giving this signer instance in this contract. And then we can actually, so I have written this function initialize, where I am initializing this, like I'm naming this my token empty, and I'm going to define 18 decimal places just like Ethereum, and then I'm going to wait for this initialization, and finally the contract will be initialized. So what I can do is I can run this initialize function. It's not main, it's initialize. So first of all, I need to upload the smart contract. If I go to scripts, deploy.js, I have to change it. So I'm just going to copy and paste the script which can be used to deploy the contract, and I can just simply go to npx hardhat run --network volta scripts / deploy.js. Let's wait for this contract to be deployed, and then we can use the address to communicate with the blockchain and the smart contract deployed on the blockchain. So this is the contract address. Let's go copy and paste here. You can use Matic network too, but I'm comfortable with Volta, and I have some coins, the test coins, so I'm just checking it from my Volta account. So in the index, it's going to get the private key, the signer. So basically, let's try to run this, and also like try to, once it's done, we can also try to get the name. So we can actually copy and paste these things here. So basically this, it's going to get the name of the token, which is my token, the symbol which is empty, the decimals which are 18, and the total supply which is going to be minted in this, and finally this is the address. So this private key, if you see here, it corresponds to this blockchain address 0x6541, and we are going to see the balance. So if you go to the token contract, it's going to mint, and it's going to send this to this message.sender. So this account will be filled with these minted tokens. So we must see 1 million tokens in this account. So let's go and write node index.js. Let's wait for it to be initialized, and then we can see if the minted tokens are assigned to this address. Oh, I did not save the file, but it's, I mean, it's okay. I can create another function, async function main. I cannot run this function again, because if I run this again, I will be getting an error, because this initialize function, it can be run only once. It's just like a constructor. For every constructor, it can be run once, and you cannot run it again. Either I need to deploy a new contract, or either I need to write another function to test everything. So in the async function main, I can copy and paste these things. So instead of initialize, let's write main and write, yeah. So basically, you see, I have minted 1 million tokens, and the balance of this address is 1 million. So all the minted tokens are transferred to this address. So we are going to write some tests, and we can so let's say there is a recipient. So if I just go here, so if let's say this is a recipient, this is also another address, and I want to send some tokens from this address to this address. So first of all, I'm going to convert it to the smart contract readable form using parse units, and you are going to represent these tokens in the form of decimals, because you are going to multiply it with 10 power 18, and then you are going to call this function contract transfer recipient and amount. So it's going to transfer the tokens from this address to this address, and we can wait for the transaction, and finally we can see that the tokens are transferred. So we can see the new balances. So if we just like see balance is equals to await the balance of, so it's going to return the balance of these two addresses. So let's try to run. First, it's going to send the tokens. That's why it's taking time. It's writing the transaction in the blockchain. So you see, like it had 1 million coins. So now 1000 are transferred to this address. So now it has 999000 coins. So once these coins are transferred, so what we can do now is, let's say we define a new contract, and let's copy and paste this here, contract balance, const balance is equals to, okay. So now we know the balance. So okay, so this function, we have another account with a private key. So basically this is the private key of this account. So what we are doing now is, we are sending a transaction from this account, and we are creating a new instance of the contract and new signer. So we are getting the owner of the account, and then we are allowing this address like 0x6541, which is the owner of the contract, to spend the token on his behalf. So basically it is allowing that he can spend 1000 tokens. Sorry, so I cannot remove this amount because it will be used, so I can remove everything from here. And okay, so it's going to allow the spender, this address 0x665, to spend the tokens on his behalf, and this function is going to give us that owner can now spend on the behalf of new signer. And then we can see the spend amount, like how much tokens this address can spend on behalf of this address. So we are going to get these tokens, and finally we are going to now this address 0x6541, it's going to run this function transfer from where the sender is this. So this function, this address is actually going to call this function, and he's the sender and the receiver is the same address, recipient 2. So basically it had transfer 1000 tokens to this address 0x01. So now it's going to transfer 900 tokens again back to his own account, and then we can see the new balances. So let's try to run this function. First save it, try to run this function. So we can see owner can now spend the tokens on the behalf of new signer. Yeah, so if you see, before the tokens were 999000, but since it has transferred 900 tokens again back to this address, so now this address tokens are 999900, and now this address 0x01, it has these tokens of like it has just 100 tokens. So basically that's it. You can create your ERC20 tokens, and then you can create a file that interacts with the token. You can allow someone to spend on your behalf. You can transfer the tokens directly from one address to another, and then you can use transfer from function to actually transfer the tokens from sender to receiver if you are the legitimate spender. So yeah, that's it. So thank you for watching and take care. Bye bye.